Yeah, can you guys see the presentation right now?
Yeah, yeah.
Oh, sweet, thanks. Okay, yeah, so today we're just gonna go over the first algorithm that, it's pretty simple. It's just like prediction AI algorithms. So most of this lesson is gonna be in part 3 here, where we're gonna do an example of predicting the stock market. But first we're gonna go over what a prediction algorithm is, and then what it does, and where it's used and what cases it can be used for. So first of all, I'm sure you guys have seen images like this before, correlation. That's pretty much what prediction algorithms do. And this is a pretty simple correlation, because it's just one input to one output. It's possible for AIs to have multi-dimensional correlation. So it could be like, if you imagine like a 3D graph of this, and it finds the correlation between 2 points and a third point, or even more than that. You could, the more dimensions, the more complex the algorithm gets. And as well, it's important to understand that it can be different types of equations. So for example, these are all quite linear, except for this one, which is no correlation. But this one, a linear line correlation would not work quite as well. It'd probably look at something like here. But when you do a polynomial correlation, it's much more accurate. So depending on what data you're using, you have to consider what type of function you're going to be using to correlate it. So what it can do, this is an example of what we're going to be seeing later today in the later in the lesson. And this is looking at 3 different types. So the linear model, which is the purple line right here, as you can see, it doesn't match the black lines too well. And then there's the polynomial model, which is a little bit closer, but still not very good. And then there's the RVF model, which is much better, because it's a function between the 2 points instead of like one continuous function, like it's multiple. But there are many other types of functions that can be used for correlation. So it's very important when you're using an AI like this to research the different types of functions, and probably either, if you can graph your data, that'd be great. But if not, you can just try multiple different types, which is exactly what we're doing in this example. We're just trying multiple different types, and you can see which one is best, and then you can work from there. Yeah, so like it's quite often used in stock market predictions, as we're about to be doing, and then sports bet guessing, and I think that makes sense a little bit. You look at the data and you try to correlate it with if they're going to win or lose, or if a goal is going to be scored or something like that, as well as multiple other things. So do you guys have any questions about what like prediction algorithms are, or like about correlation, before we go into an example?
No, I'm good.
Sweet, okay. Yeah, sweet. So these are some links to, if you guys want to follow along, but I will be doing it here on my computer also. Sweet. So I'll just clear this when I was using it before. Oh, sweet. All right, it's already cleared. Okay, so pretty much what we're going to do is we're just going to make a simple model that's going to look at past data, which is downloaded from Yahoo Stocks. I downloaded the data earlier today. It's pretty much just a CSV which is a comma separated value, pretty much an Excel document, just the date when it was opened, the high, the list of the stock market of a certain stock, just throughout from 2019 all the way up to 2020 here. So what we're going to do is first we just have to import all the libraries we're going to use. So these are very similar libraries to what we used on the last example we did with breast cancer. They're mostly for just computing, just holding the like matrices and different ways of computing data. They're quite common. They're going to be in pretty much all the code you guys use. So just run that to import the library. And then the next step is you have to import your data. So it's very important that your data is formatted. You have to know it's formatted correctly, since you're going to have to parse it later and like pull pieces out. So this data came quite nicely in a CSV, which is very easy for us to take data from. So if I upload the file from downloads right here, you'll see when I hit this won't change since it's the same data, but this is what the CSV showing. So it's this is just to look at kind of what we have and make sure everything came in correctly. So this all looks good. And then here, what's happening is we're taking the an array of the actual price of the stock per day and just saving it into an array. And here we're just checking the data without the one that we pulled out for the actual price of that one day. So these three lines right here are not, these two, sorry, this section here and this one right here. These are just for inspecting the data and looking at it. It has nothing to actually do with the algorithm. So once all of our data has been imported, we have to set up the data in a way to give it to the AI to learn easily from. So we just create an open list of days and the adjusted prices on those days, because those are the two important pieces of data, like the day and what it ended on, so it can see the trend and try to learn from that. All the other pieces like the open and the high and low doesn't really matter. It's just like the final price on the day is what we're trying to correlate. So once we've created these two lists, we're going to use them down here. And we're going to make two more lists that hold everything in the date section here. So it holds all this. And then we're also making one that holds all of this here. So we're just populating those arrays. That's what this here means. And once we run that, those will be populated. And then here, what we're doing is, this doesn't mean, that's just a comment, we're just training on one day, 1 month instead of the whole data. And it's just for simplicity of the example. It's not necessary to do that. So here we're just adding onto the days and adjusted close prices, the data set of that 1 month instead of the whole data set. So we're just, those are just holding the values that we're actually going to give to the AI to learn off of, while these are holding all the values, if that makes sense. And then once we have our data in two arrays and they're correlated, so they're all matching, and we can print that out. Oops, sorry, I didn't run this code. We can print that out to see. It's just the 30 days and then the adjusted closing price of each day. And they're all matching indexes. So the whole section above this is just really setting up your data in a way that the AI can learn from it in a meaningful way. That's a massive part of all AI projects. So finally, right here is where we're training the three different algorithms. So there's the linear, the poly, and the RBF, which is radial bias function, as you were talking about earlier. So that's the one that looks a bit more spiky and all over the place. This is it's not a very small amount of data, and it's also, it's not a very complicated AI, so it's going to be extremely quick to train, practically instantaneous. So now that AI has been trained, we can take a look at what the data looks like. So this is what it looked like for my last run. If I run this, it looks probably a little bit different, but probably extremely similar, since it's a very small subset of data. So there's not much room for variance. So again, you can see that the RBF function is just far better than the other two functions. And that's just because of the data set that we're using and the type of data we're using. And then this final section right here is just kind of proof that it works. So if I take the 29th day of the month that we trained on and I check what the price is, I get 1567. And if you scroll to here, the 29th day, it was 1567. And what's interesting is if you look at the other prices, you can see they're quite far off. And that's just because of that RBF is a far more accurate system. And I'll do one final example where I'll change this month to 09, just so you guys can see that the AI is it truly is learning off of the data. So I'll just run through this one really quick. It's going a little slow. Same file, but we're just going to use a different month here. So the data will look the same. This will all be the same here. And then when we got here, the month I've changed it to 09 instead. So it'll be a little bit harder for us to check the data. We can open the CSV to do that. So when I run this, you'll see that the numbers will change here a little bit. So these numbers have all changed now. And then we'll train it once more, and we'll be able to see a much different graph. Much different. It didn't reset the runtime from last time. It trained on 2 data sets. That's why it goes back. That's why it's going back and forth actually right now. However, that is the basic concept kind of how a prediction algorithm works. Each one will look different, and there'll be a lot more variety of, you'll probably be using a lot more data, and it'll be probably a little bit more complex in this example. However, this is a quite good of a baseline of just how they work and what they can do. See, this is what the graph looks like for last month, or for September. So quite different. And then if we were to run this, the prediction's different, and I'm sure quite accurate. 1469, and this one is 1469, and you can see these ones straight once again. So that is my example of a prediction algorithm. Do you guys have any questions about what I went through? If I went too quick, I can go back over something.
Can you explain just how the RBF actually kind of works? How does it know?
Yeah, so I don't know a ton about radial bias functions. It's similar. It's like linear, I don't know, it's the similar difference to like a linear to polynomial function. It's just, it's a different mathematical function, different mathematical way of representing a graph line that's more complicated. So like you know, like there are linear models of lines which are just straight lines, and then when you go to polynomial, it's all with squares, right? And then RBF will just be a similar type of difference where it's just it's a different like base equation that you're using to represent this line. I haven't learned a ton about them. I just kind of know how they're used for prediction algorithm, and they're often the best.
Yeah.
I don't know if I'll post something along with the PowerPoint about how RBFs work. It will get a lot more just math though, yeah. Just so you know.
Yeah, I'm sure it's really complicated.
Good question though. Do you have any other questions?
So like this was trained, but does it actually like predict data going forward?
Yeah, it definitely can, because it would use the same equation to extrapolate the data in the future.
Yeah.
So for example, if I go back to this image here, if you calculated this much data, right? And then from that, and then you have this equation of this line, from then on, whatever value you're given, no matter where it is, you can use that equation you've built off of this data to guess what it is. Right. So that's why like the data, when we make the guess here, the way you know it's a guess is because it's not exactly right? It's using this prediction. So when you train one and you want to actually deploy one and to be very accurate for the future, you have to get far more data than just 1 month. You'd have to get like for stock markets, you'd want to get like years and years, like decades, or to try to get the most accurate function for that massive amount of time, hoping that the future will follow the same trends that the last many years as possible has. Does that make sense?
Yeah, that makes sense. And like if you did train it for like multiple years or on a big data set, and you can, like, how accurate do these things actually get? Like can they predict it within like a reasonable amount? Like is it or can it just be
well, for stock market, it's this is not the data this is trained on is quite bad for predicting the future, since the stock market doesn't really follow. It does follow trends, but it's influenced by a lot more than just what day of the month it is or what day of the year it is. To make an actually a strong stock market prediction algorithm, you would definitely have to get more than just the day of the month to correlate to the price. You'd have to get that's kind of the innovation. Is like what
factors influence like the I guess. Yeah, okay, that's super interesting. And like I guess if you could also look at like which stocks tend to go up together, and you can stocks, and then like figure out which stocks have the highest comparison.
So I think that's like one of the most important parts for it's just finding the data that you think or that gives you the best results. Finding what you can correlate without making it too complicated and slow on the AI and adding unnecessary stuff.
Yeah.
So.
Okay. Well, that's cool.
Yeah. Anything else?
No, I think that's good for me.
Sweet. Anything from you, Jessica? Not a problem. Okay. Yeah, well, I guess if you guys have no more questions, I'm going to stop my share. And I'll stop the recording.